The overall goal of this procedure is to develop macroscopic nanoparticle-ligand monolayer films. This is accomplished by using a single one-pot self-assembly technique. First, metallic nanoparticles are rapidly functionalized with ligands in a water tetrahydrofuran, or THF, solvent. Next, the ligand-capped nanoparticles phase separate to the air-solvent interface. Finally, the nanoparticles are transported onto template-free substrates using surface tension gradients, self-assembling into macroscopic nanoparticle-ligand monolayer films. Ultimately, this procedure provides a simple, robust, and scalable technique to functionalize and self-assemble macroscopic nanoparticle-ligand monolayer films onto template-free substrates.
The main advantage of this technique over other interfacial assembly methods is the rapid and efficient nanoparticle functionalization and self-assembly into macroscopic monolayer films.
Though this method can provide insight into the organic and inorganic interface at the nanoscale level, it can also be applied to a wide variety of applications such as metamaterials, photovoltaics, and molecular sensors.
To begin, concentrate commercially available 15 nanometer gold nanospheres by placing 15 milliliters of the dilute nanosphere water suspension into an ultracentrifugal filter. Then centrifuge the unit at 4500 Gs for 2 minutes or until only a few microliters remain in the filter chamber. Resuspend the nanosphere in 1.5 milliliters of deionized or DI water, or such that the nanoparticle concentration is approximately 10 to the 13th particles per milliliter.